So today we're going to continue with fractional equations and solving them. I'm going to show you three solutions, and in the first one I'm going to show you both methods. In the other two I'm only going to show you the second method. Just talking about fractions and why we can do certain operations. So looking at this first thing where it says 1 plus 2 divided by 2. Notice that I could write this as 3 over 2 because I can simplify the top piece, and then the bottom is the denominator is 2. This is, when we look at this, also note that this can be written as it's 1 divided by 2 plus 2 divided by 2. So 1 divided by 2 plus 2 divided by 2. Oops, there we go. Just in the same way, we can now add the numerator, which is 3, and the denominator is 2. So just be very, very careful when you're going to separate a fraction. Make sure that you're following the correct steps. You cannot just simply cancel these two 2's out and make them go away. That is not one of the mathematical steps that you can do. So solving the first one. So I'll show you both methods. Method 1. This is when we split the fraction apart. So what we actually have is 2x divided by 4 minus 1 divided by 4 is equal to 5. Now we're trying to get x equal to something. I want to know what the solution for x is to make this equation true. Therefore, what I need to do is I need to get all of the x's on one side and everything else on the other. This is the thing that's making the 2x over 4 not be on its own. So I'm going to simply add a quarter to each side. And the reason I'm adding a quarter to each side is because something that's negative plus itself, so something that's negative plus itself, is going to equal 0. Which means what we're left with is 2x over 4 is equal to 5 plus 1 quarter. Alright, so I'm going to add these fractions. So on the left-hand side, notice that the common denominator is going to be 4. So I get 20 over 4 plus 1 over 4. And I can simply just simplify this side. I don't have to add anything. So I'm going to rewrite this as a half times x. And then I end up with a half x is equal to 21 over 4. Now remember, I'm trying to get x by itself. So notice that if I multiply this side by 2, I'm going to write it as 2 over 1, then these 2's become 1, and all I'm left with is x. Whatever I do to one side, I must also do to the other side. I'm also going to put this over 1, and therefore I can simplify this, and the 4 there becomes a 2. What I'm left with on the right-hand side is x, and x is equal to 21 over 2. So this was method 1. Remember, if I put this back into the equation, I can check this to make sure that the left-hand side does in fact equal 5. On my other piece, so my other method, we learned yesterday, I'm going to write out the equation first. Remember, 5 is just considered to be 5 over 1. So if I'm looking for the lowest common multiple between 4 and 1, I would say, well, that's pretty easy. The lowest common multiple is just equal to 4. So if I multiply both sides by 4, okay, remember you might right now want to put this top piece in brackets. Okay, with this question it's not going to matter so much, but maybe get into the habit of it. So what I really have here is 4 multiplied by 2x minus 1 over 4 is equal to 4 times 5. And the nice thing is that these 4's will become a 1. So all I'm left with is 2x minus 1. And then this is equal to 20. I can add 1 to both sides. I get 2x is equal to 21. I want x equals, and therefore I'm going to divide by 2 on both sides, and I get x is equal to 21 over 2. So I got the same solution. It was a little bit easier. If you do want to check this, okay, let's do one example of checking it. So my equation was 2x minus 1 over 4 is equal to 5. Wherever I see an x, I'm going to substitute in 21 over 2. So now over here, I have, this is where my x was. just so that we're all aware. I'm going to write this over 1. The nice thing here is that the 2's are going to cancel out. So now I'm left with 21 minus 1 over 4 is equal to 5. 21 minus 1 is 20 over 4 is equal to 5. And 20 divided by 4 is 5. So I got the right answer. So my answer is x equals 21 over 2. Alright. Example 2. Okay, so all I'm going to do is the second method here. So what I have is 2x over 5 minus x minus 3 over 7 equals 2. The lowest common multiple, now remember this is really 2 over 1. We're just looking at the denominators. The lowest common multiple between 5, 7, and 1 is equal to 35. So I'm going to multiply both sides by 35. And right now I'm going to put this top piece in separate brackets. Remember that this is multiplying every term inside the brackets. So what I have is 35 multiplied by 2x over 5 minus 35 multiplied by x minus 3 over 7 is equal to 35 multiplied by 2. You can write the 2 over 1 there if you want. It's not really needed, so I just dropped it. The reason I wrote this 1 over here was so that you knew we were looking at all of the denominators, and the denominator for 2 is actually 1. And I can simplify things here. Okay, so using our knowledge from last unit in rational expressions, this is as if it's over 1. 35 divided by 5 is 7. 35 divided by 7 is 5. And there's nothing else that I can simplify there. So what I really have here is 3 multiplied by 2x, 7 multiplied by 2x, minus 5 multiplied by x minus 3 is equal to 70. So this is 14x, and this is why those brackets were so important here. We're multiplying everything inside of these brackets. So it's minus 5 multiplied by x, which is minus 5x, and it's minus 5 multiplied by negative 3, plus 15. This was really important. Okay, this is why we got that plus sign there. Is equal to 70. Now remember, our goal is to solve this. I want to know what x equals. So I want all of my x's on one side. It doesn't matter which side they're on. And I want all of my constants on the other side. So here it's super easy. I can look at this and I can say, awesome, this is just 9x. And I still have this plus 15 is equal to 70. I can subtract 15 from both sides. And I get 9x is equal to 55. And then if I divide both sides by 9, I get x is equal to 55 over 9. And this is my solution. Next one, a little bit bigger. I'm going to do it the same method. Okay, you could have split it up if you wanted to, but this method takes a lot less time, and it really proves that you understand the rational expressions unit as well. So my lowest common multiple between my denominators of 4 and 5 is equal to 20. So I'll write this down. I've got x minus 4 over 4 is equal to 3 multiplied by x minus 2 over 5 plus 1/4. Now I'm bracketing both sides, and I'm multiplying by 20. So what I have here, and I'm going to put brackets in here, I've got brackets there, so that's okay, is 20 multiplied by x minus 4 over 4 is equal to 20 multiplied by 3 multiplied by x minus 2 over 5 plus 20 multiplied by 1/4. Be really careful. Remember, we're distributing. And now we can start to simplify things. 20 divided by 4 is 5. 20 divided by 5 is 4. And 20 divided by 4 is 5. And so here I'm left with 5 multiplied by x minus 4 is equal to, this is super easy, 12 x minus 2, right? 4 times 3 is 12, and it's still multiplied by x minus 2, plus 5 times 1 is 5. Now we've got to distribute. So what I get here is 5x minus 20 is equal to 12x minus 24 plus 5. Remember, my goal is to solve for x, so I want to know what x equals. So here I'm going to subtract 12x from both sides. Okay? When I subtract 12x from both sides, I get negative 7x. And then over here, I'm going to add 20, and I'm going to add 20 to this side. So really what I have now on my right-hand side is negative 24 plus 5 plus 20. And negative 24 plus 20 is negative 4. And then negative 4 plus 5 should leave us with 1. So I've got negative 7x is equal to 1. And then x is equal to 1 over negative 7, which we don't like to write this in the bottom, and therefore acceptable answers would be on the top or in front. Either of those are sufficient. And we're done.